Now let's talk about data science. And the first data science skill that everyone really loves talking about is machine learning. There's a lot of stuff on here. I personally really love machine learning, so it was hard for me to kind of break down the different things. So when we think of beginner machine learning skills, we definitely want to have knowledge of the machine learning pipeline. So this includes things like getting your data, having the feature engineering, doing the feature selection, model metrics, and being able to understand and implement, or maybe not implement, but be able to use some of the basic algorithms. So some of these algorithms could be your linear regression, your random forest, your decision trees, XGBoost, boosted trees. Maybe you start diving into some of the deep learning. But the hallmark of a more of a beginner machine learning practitioner is just being able to just import and use some of those packages without having to think through too many things and be able to get to the result. So for this one specifically, I actually think Kaggle is a really great place to learn some of these skills. I know a lot of people bash Kaggle because they say things like, oh, but your data set, you just get given your data set. In real life, you don't get given your data set, which is, it's not entirely wrong, but definitely Kaggle has its place for learning some of the machine learning steps, especially some of those pipelines. And I'd argue that a lot of the guys that are participating and competing in Kaggle, they're really at like the cutting edge of all the different technology and the different methods that you might be able to use for, say, your feature engineering or the feature selection or the model selection or different things. So definitely if you want to become an expert in machine learning, I wouldn't say that you need to go to Kaggle, but it's somewhere that you should at least investigate and try and find out more about what other people are doing in that space. So that's that. If anyone disagrees or if they have any different ideas or whatever, please feel free to put it in the comments and we can talk about it straight away. For intermediate, here I've put hyperparameter tuning as one of the core things. So for people who haven't done a lot of the machine learning, hyperparameter tuning, you can think of hyperparameters as all these different knobs on this crazy machine that you can kind of turn up and down and fiddle around with them until it gives you a different model score or an output. The hyperparameter tuning is where there are a few different methods where you can kind of figure out how to turn those knobs to give you the best result. And you get to define what the result is. So you might have different metrics. You might have heard of things like RMSE, root mean squared error, or you might have, there's a lot of them, say log loss, or different metrics, maybe accuracy, AUC, or different things like that where you can choose what metric you want to optimize for, and the hyperparameter tuning just kind of changes all these knobs in a very systematic or random way, or you can manually figure out how you want to do your hyperparameter tuning to get the best model. So yeah, definitely I think intermediate level for hyperparameter tuning, you should be able to know what you're doing, understand the different types of hyperparameter tuning. So there's like grid search, random search. Maybe you can do different things like cross-validation with some of those regimes, k-fold cross-validation. Maybe you want to do, if you're more advanced, you can do Bayesian hyperparameter tuning, where it kind of does it sequentially and identifies a space where it searches for a different set of hyperparameters to tune on. But yeah, the area is quite deep, but I think for intermediate, you should be able to at least know like the grid search and the random search and be able to explain the differences between them. The rest of it might be more advanced, and you can definitely spend some time learning it. These days, I think Bayesian hyperparameter tuning is very popular. So yeah, definitely give that a go and see how it goes. The next one here is applied machine learning for business. Generally, machine learning in and of itself doesn't really have any value. It only has value when you use it and apply those outputs to something. And most of the time, it's being able to understand the business problem and have enough domain knowledge to actually link, oh, I can do this machine learning task with something which is related to the business and actually solve a problem and help them make a decision. or help them target the right customers or different things like that. Okay, the next one here is algorithm internals. So when I think of intermediate machine learning skills for data scientists, I think of you should be able to, at least in maybe not in too much detail, but you should be able to express in pseudocode what the, say, a logistic regression, what's going on under the hood. How is the loss function calculated? How does it get updated? What sort of gradient descent things that's going on underneath? Maybe for a random forest, you might be able to explain all the different bagging methods and different things like that are under the hood, that if you were to just use those algorithms, you don't necessarily need to know. But as an intermediate level machine learning practitioner, you should be able to at least talk through some of those things in a lot of depth, and like at least know enough to kind of say, okay, here's the general concept. If you told me to write down the math straight away, maybe you don't need to do it. Most of the time you could just go to Google and just take a look at it on there. But I think, yeah, definitely if you could try and implement some of those algorithms from scratch, it would be very good. But it's not a major thing. I wouldn't have to pin all of your knowledge to that as well. Okay, another thing will be model interpretability. So these things might be, okay, your model comes out and the score is really good, but why? So there are different tools. You can use your feature importance. Maybe you can use something like LIME, which is, I forgot the actual acronym, what it stands for. I think it's like locally interpretable machine learning explanations, model explanations. Yeah, I think that's it. But there are different technologies and packages and things that you can use to explain why your model is making a certain prediction. Having that knowledge is definitely within the intermediate practitioner space, and you should definitely learn it. I think it's super important. The next one here I've put is automating pipelines. So here, by pipelines, I mean those simple machine learning pipelines. So maybe here's where you start thinking about AutoML, for example. So say you have your data set, you want to process specific parts of your data set and the features in a specific way. Can you code up certain functions or recipes that you can just apply to the data to start automating more of that, the dirty data cleaning work? The last thing that I have here is maybe they'll start reading and taking an interest in some of the research papers in machine learning. At the moment, there's a lot of research in the deep learning space, but there's definitely a ton of research in other things also, such as recommendation systems or being able to explain the models better. So like the LIME and the Shapley and the different things like that. I think just, yeah, when you talk with someone and like one of the best ways to demonstrate your passion for machine learning is to start reading some of the research papers and try to find out what some of those guns at the cutting edge are doing and trying to understand what they're doing as well. I think that's super cool. And usually when, let's say, a hiring manager notices that one of the people likes reading some of the papers, it's pretty impressive. Even if they can't implement it or they're not working in that field, just having that interest and demonstrating that interest by knowing what the research is about is pretty cool. Like, I think it's pretty cool. So yeah, definitely, if you're super interested in machine learning, you should be reading some papers. I think you'll really like it. Okay. Now for the advanced machine learning. Like, I'm sure there's tons of stuff that I've missed in the intermediate and the beginner level of machine learning, but it kind of, at least this gives you a flavor for some of the different levels that are there. So when I think of the advanced machine learning, we're thinking of people who actually do research. They're trying to build new algorithms, or they're working on some actual algorithm, say like scikit-learn or something. And they're making contributions and they're actually coding some of the code base. So you know that they're pretty advanced. That's pretty hardcore. That's really awesome. The next one could be, here I've put understands trade-offs. So this one's more of an experience play. So when we talk of trade-offs in machine learning, it's in the way where you think of, okay, we can use a very complex model and it gives us, say, a 95% mean average precision, or 95% accuracy or something. But if we were just to use a very simple model, say a linear regression or something, we would actually get 93% or 94%, and it's very easy to train, very easy to deploy. It's just very simple to manage, and a lot of the processes are very cheap and easy to do. So I think, when we think of trade-offs, they're in terms of cost trade-offs, management of code-based trade-off, tech debt trade-offs. So it's more around the operational aspect, as well as some of the technical trade-offs also. So some of the different algorithms might work with different types of data sets. But that's more of like you get into it more and more as you think through some of the different scenarios that you might be using machine learning. But this one comes more with experience, I think. Okay, so the next one here is production machine learning. So anything in production is where you set it and forget it, or not really forget it, but you set it in some process where it just automatically continues running your model, extracts the features from wherever it needs to get it from, scores them, and publishes those scores somewhere for some downstream system to pick up or use in a campaign or different things like that. So it's kind of like machine learning automation, but with all the different data bits connected as well. So definitely it's a more advanced skill, but we're seeing more and more these days. This production machine learning is starting to move towards the intermediate machine learning practitioner space skill set, because a lot of the production work is becoming more and more apparent. That's where a lot of people need to focus on. So what we're seeing is production machine learning experience is super, super important. But at the moment, not too many people have it. But over time, more and more people will have it, because we need more of the machine learning solutions in production as opposed to being ad hoc and experimental. So just something else to keep in mind as well. Another advanced machine learning skill will be experimentation with machine learning. So these could be in terms of testing different algorithms on a specific problem, in terms of setting up how you might do the actual machine learning problem in terms of the hyperparameter tuning and the model selection. But in terms of this one, when we think of machine learning experimentation, it's more around how will you use your outputs from your model, and how can you build experiments to actually calculate the uplift of something, or how do you compare two models in production in a very specific way. So it's more around a statistical analysis of the machine learning outputs, as opposed to having deep machine learning experience. So I think it's still super important to have the machine learning, but think of this as like a next meta level of machine learning experience and skill set, where you're kind of abstractly looking at the machine learning models and thinking how you can run experiments with them. So it's pretty cool and kind of abstract, but over time, I think more and more people will be moving into the space, so don't worry too much. And the last one here is embedding machine learning into existing processes. So this one ties in very much with the domain knowledge that we talked about with the data analyst. But in this case, instead of understanding all the different data inputs and all the different things like that, a great machine learning practitioner will be able to pragmatically navigate through all the things that are happening within the area where they want to use their machine learning model, and then they'll be able to talk with the people and communicate with the people that they need to convince to actually get their solution to be ran in a test, for example. All these different things are very important, and they're more soft skills, but you see them more in more experienced machine learning practitioners, because it's one of those things where you just need to do it to actually get your project out the door and to actually have a successful project. So definitely super, super important. Okay.